Okay, dear students, in the last class we have finished limits, all complete limits. Exercise also have finished. We understand what are limits and what were the special cases. Okay, case 3 how to make it into case 1 or case 2 like we have seen, and exercises we have done. Okay, now this chapter is limits and derivatives. That means we have to see derivatives also. Okay, we will see derivatives also with examples. Afterwards only we will go for exercise. Okay, examples along with the derivative concepts, examples also we will see. Let us see derivatives. What is derivative? First, what definition or how to understand the derivative? See, something I am writing. First, you understand the statement. Okay, you see what I am writing. Derivative is the measure of change in function. Okay, derivatives are the measures of change in functions, or derivative is the measure of change in function. We are talking about only one derivative. Derivative is the measure of change in function. First, you understand carefully. This change is very important. Change. If no change, no derivative. That means for constant function there is no change. That means constant function doesn't have derivative. That means constant function's derivative is 0. You understand first? Logically you have to think. This change is very important here. The word change. Derivative is the measure of change in function. If any function normally change is there, then derivative will come. If change is not there, derivative doesn't come. That's all. Okay. You see here, one simple example I am writing fx is equal to 2x plus 3. This is a function. You tell me, is there any change if you change the input? See, normally f of 1 will be 2 into 1 plus 3. That is equal to 2 plus 3, 5. F of 2 that is equal to 2 into 2 plus 3. That is equal to 7. 4 into 3. 4 plus 3, 7. Okay. F of minus 1 that is equal to 2 into minus 1 plus 3. Minus 2 plus 3 plus 1. F of minus 2 that is equal to 2 into minus 2 plus 3. Minus 4 plus 1 minus 1. Minus 4 plus 3 minus 1. You see, if it goes on change input, the output is also changing. Okay, normally fx we will take as y. Okay, if you plot graph, then fx will be y, x input will be on x axis, like we will write. Okay, here if you observe carefully, there is a change. That is why derivatives will happen here. Okay, see, will happen here. I am not telling that this is derivative. Will happen here. Okay, what about this one? Is there any change? Why? Because here for changing no variable is there. Constant function or scalar function, like this is a scalar function, constant function. Okay, constant function or scalar function doesn't have any variables, then the function value irrespective of input, the same value is going to come. That means there is no change. There is no change in constant function. That is why derivative of a constant function is 0. First of all, see what will be the derivative. This we will go afterwards. Let us understand here. Now, shall I write derivative is equal to 0 like? Because see, we will prove that also. But even then, with this statement, we can say that derivative of a constant function is 0. Because there is no change. Okay? Now, let us go what is derivative. And with the graph, we will understand properly. Okay? Okay, see, how I am drawing or plotting the graph and all. Okay, and observe carefully. Say this is y-axis. Say this is x-axis. Okay. Say some point x is there here. This is small x is a point or input. Whatever input we are giving, that we will plot on small. This is capital X, xy. Okay. Accordingly, some result has come. You see, on the graph also I am drawing. One function is there, like you think. Why? Because see, without function we cannot see. This function is not a constant function. That means if you change input, then output is also changing. If you see here, if x is 0, then y is also 0. If x is something, then y has also changed like this. See, we don't need to know about this function. What is that function? For understanding our derivative, this function is dependent on x, like that you think. Okay, that means y is equal to f of x, right? Okay, I have given some value here. Accordingly, y will come. Okay, is it okay? First you understand, step by step we will go. First you understand this. This is a graph. We are plotting graph of a function. This we don't know. Y is equal to f of x. Okay, some function is there. Y is equal to f of x. I have not written y is equal to x square or x cube or x3, x to the power of 4 or something. It may be, let it be. Y is equal to f of x. This function is there. Input to we will plot on x-axis. Normally, output we will plot on y-axis. But shall I write this y as fx? Definitely we can write. This practice we have already made. Y is equal to f of x. Okay. Okay, I am writing now. You see, f of x. Okay. Now see, input, output. Output we will normally, this is the function. For function input we are giving. Okay. Now, what if we change small change, not also big change? What I am talking about, small change. Say here I am keeping. Now, okay. See how much I have increased. Say delta x. This delta is very important. You understand? Delta x. This is delta. Small delta. See, delta symbols are different. This is also delta. Okay. This is also delta. Like yes, you write and close this O. Bottom, if you close O, see, if you write this 8. If you write this yes, if you close this, this is going to become delta. Okay. This is the symbol delta. Delta you have to call. See, different authors or different books, they give different symbols, but delta is a standard practice from foreign. Okay, that you practice. This is very good. Delta represents for small change. We are changing a small, that means we have increased. See, delta x, this plus side of x. X is say 5, then delta x may be 5.5 or something like small. Limits also have analysis made with small change only, small, slightly positive or slightly like that. Here also slight change you have made, like you think delta x. Okay. Accordingly, this also going to change, but here delta y is not there. You see what I am writing. Okay. Or else I will write this as x plus delta x. Okay. See, when input is x, function is f of x. When input is x plus delta x, the function is f of x plus delta x. Why? Because see, in x plus delta x you have to write. That you keep in your mind. In x plus delta x you have to write. See, this is the change in function. We have changed the function. but we have to make measure also. Why? Because derivative is the measure of change in function. Okay, how we are making a change in measure of function? You see, limit x tends to 0, f of x plus delta x minus f of x divided by delta x. See, first I have written this, but before that we will see one by one we understand. Okay, what is delta x? You see delta x I am writing here again. Okay, here x plus delta x minus x. What will come? X minus x going to get cancelled. Delta x is going to result. You understand? That means this portion we are taking here. This portion is delta x. That's all. See how much increment we have made. Increased, changed. How much change? How much increment we have made? See, for understand the concept, first to understand this, you take this as positive only. Positive. Delta x is positive here. Increased. Okay. Small amount we have increased. That small amount is x plus delta x minus x. If you make automatically, directly it will come. Okay. What about function? How much function it has been increased like? Is it okay? See, for this delta y is not there. You cannot write delta y. Okay. You have to write this only. F of x plus delta x minus f of x. Understand? Because you see here x plus delta x minus x will come delta x. F of x plus delta x minus f of x is going to give this portion. Change in function. Change in input, change in function. Or else I am putting this, you see, red color. This is a change in change in input. This is change in function. Okay. This red line. This red line. That ratio is the measure. Why? Because see, this much we have got change in function. This much we have changed the input. Have changed the input. This much we have changed the function. That is the measure. Where limit extends to 0. Why limit extends to 0 also I will tell you. Okay. See, if you take this point as P, this point as Q, and if you extend here, it will touch this point as Q, R. Is it like a triangle? First of all, you see, PQR is a triangle or not? Definitely triangle. Why? Because see, you have extended this line. It has touched R at this line. X plus delta x line, R. And the topmost part is QP, and see, this is Q. See here, P and Q should touch this function line. Function line, okay? And R is extended portion of this one, okay? Now again I am writing here, you see. This is Q, this is P, this is R. Is it correct? First, this triangle you observe. Okay, definitely correct. You see here, this angle may be theta like. Okay, but this is a slope. In our geometry, y is equal to mx plus c. This m is slope. The slope is this one only, theta. Then how to find this theta in rather than trigonometric angle? How to find tan theta? Tan theta how to write? Opposite side by adjacent side. QR by PR. Is it okay? First you see, tan theta is QR by PR. I am writing slope. Slope is an angle only, slope. But slope you can represent in constant form also. How can you represent? If you take any trigonometrical value, then automatically it will come in a constant value or any value like, rather than in angular. Tan theta is equal to QR by PR. Why? Because opposite side by adjacent side. That gives tan theta. This is slope. Okay. See, if you think logically, what is QR? What is QR? QR is change in function. This one. QR is change in function. You see, QR, if you increase this delta x, QR also is going to may increase. Okay. Okay. If you increase delta x, automatically PR will increase and QR also will increase. Why? Because function also going to increase. Na? Positive side we are talking about. If you increase delta x, then this PR also is going to increase. Accordingly, QR also going to increase. Function also going to change. Okay. If you decrease, PR going to reduce, the QR also going to reduce. Until when C, the Q is going to touch P. The Q is going to touch P. See how I'm making it, you see again. So I have reduced it here. Next time this will be like this. You see. If I reduced delta x, this is delta x, na? PR. PR is the delta x, you see. PRx if I reduce half, then in half portion this line will touch. Okay. In half portion. That means what you have done here, you have reduced the delta x. Goes on, I reduce. Finally, this delta x is going to become 0. Is it okay? If delta x is going to become 0, automatically Q is going to touch P. Even R also going to touch. That is different case. R also going to touch, Q also going to touch P. That means a single one point will come. That point is going to become PQR. That's all. P, Q, R all are going to touch it. When this is possible, delta x is 0. See, that is why we are writing here delta x. Sorry, this is not x. I have made mistake. This is delta x. Limit delta x tends to 0. Limit delta x tends to 0. F of x plus delta x minus f of x by delta x is derivative. This is derivative. Okay. Now this you must have understand how to plot this graph. What are delta x? What are, see how change you have made input and accordingly output. And what is the derivative? Derivative is the measure of change in function. Change in function is this one, f of x plus delta x minus f of x. And divided by delta x. What is delta x? X plus delta x minus x is delta x. Okay. Delta x is change in input, change in function output. Input, output. Domain, range. Okay. Well, how you are measuring? You are measuring with delta x tends to 0 like that. You understand? You are measuring with delta x tends to 0. Approximately you are taking that it is reducing like you are thinking at 0, delta x tends to 0. If change is 0, then what will be the this thing like you are seeing. Okay. This is called derivative. Okay. Now you see how to represent the derivative. Okay. Now you understand this concept. I am writing how to represent this derivative. 2-3 symbols are there. Let us understand those symbols. Then we go for some examples. Okay. See here, symbols I am writing. See, fx is the function, f of x. This is the function we know. Or this you can also say that this is equal to y. Okay, f of x or y is the function. What about derivative? You write this. Now, derivative of f of x is equal to, derivative of f of x is equal to, or derivative of x is equal to. See how I am writing and all, you observe carefully. Okay, these symbols. First symbol is f dash x. F of x is a function, f dash x is derivative. Derivative of f of x. Okay, this is one symbol. Another symbol, d by dx of y. Or dy by dx also you can call. Why? Because see, when multiplication is there, dy by dx you can call. dy dx of y or dy by dx. This is also correct, not wrong. Dy by dx also correct. D by dx of y is also correct. Okay. This is one, another one. D of f of x. See, d of not f dash x, d of f of x. This is also correct. You understand? D of f of x. This is also correct. Dou y by dou x. This is called dou. Dou, not do. Dou. Okay? Not do. Do. How can you spell do? Not do. 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 Okay? Dou y by dou x. This is also correct. Okay? See how many types. Still some other may be there. When it comes, then I will explain at the time also. Why? Because sometimes second derivation, third derivations also may come. Derivative portion again you have to derive at the time d1, d2, d3 like that we have to write. Third times multiple derivations, successive differentiation or something like is there. Okay, that and all we will discuss at that time only. Okay, as on today you learn only these four. Remaining and all we will see afterwards. Function is f of x, derivative is f dash x. Don't call it as a complement. At the time only in matrices and sets, I have asked you to learn this f dash x also like a dash like along with a complement. Okay. I think in matrices transpose. Okay. In matrices it was transpose. In sets and all it was complement. Here it is a derivative a dash f dash x. Okay. Then d by dx y or dy by dx. Then capital D f of x, d of f of x, then dou y by dou x. See how many types we can represent. Okay. See, until some questions and all, first we will take only this. We don't take this that much fast. Why? Because you have to understand this also carefully. Okay. But see, this is very important. See, measure we are seeing at delta x tends to 0, limit delta x tends to 0, f of x plus delta x minus f of x by delta x is the derivative. Okay, you understand? See how this derivative and all going to change with function. We will see with examples. Okay, let us understand carefully with examples. Let us go for examples. Okay. Okay, see this question. Find the derivative of f of x is equal to 2x plus 3. Okay. So let us understand this. 2x plus 3. We will find the derivative of this. Then we will go for, this is a linear function, x power 1. Then we go for x square. Then we go for x cube. Then we go for one constant function. Okay. Then we close this class. Those examples are enough. In the next class, we will see trigonometric function also. Okay. Let us see. See, f of x is equal to 2x plus 3. Okay. Then you have to find f dash x. Then f dash x formula also you have to write first. F dash x is equal to, write down, limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Is it okay? F of, see, f dash x is equal to limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Okay? Change in input and change in functions output. Function. Okay. Now you substitute. Okay. How I am substituting? Observe carefully. Limit delta x tends to 0. Okay. What is f of x plus delta x? Where x is there, there you have to write x plus delta x. That you keep in your mind. Okay, see, I am writing 2 into x plus delta x plus 3. This entire function you have to write in this function. Where x is there, there you have to write x plus delta x. Okay, this is f of x plus delta x minus f of x. F of x is 2x plus 3 divided by delta x. First you understand this. Why? Because the first problem, this is first question. Slowly we go. This is f of x, you don't have any doubt. Minus f of x, f of x. But here only you have to observe carefully. Where x is there, there only x plus delta x will come. Remaining all terms will come. Without that, okay? 2 into x. In place of x, you are writing x plus delta x plus 3 minus of f of x divided by delta x. Okay? Now you expand this. You send 2 inside and open the bracket like, okay? Both I am doing at one go. You see what I am doing. That is equal to limit delta x tends to 0, 2x plus 2 delta x plus 3. Why? Because see, this 2 is multiplied with x and delta x only. The 3 doesn't multiply. Okay, plus 3 minus 2x. If you open the bracket, this also is going to become minus 3 whole divided by delta x. Is it okay? First you see. Is it okay? Definitely okay. Okay. Now next step you write. Why? Because see, before going next step, you make some cancellations here. You see, plus 2x minus 2x plus 3 minus 3. Then what are going to left? These are going to left, you say. Limit delta x tends to 0, 2 delta x divided by delta x. Is it okay? Okay. Now we cancel out this delta x. Okay. Then what will happen? You see, this will happen. That is equal to limit delta x tends to 0, 2. Is it okay? Okay. Now you tell me what will be the answer. It is becoming like limit of a scalar function, limit of a constant function. Then limit of a scalar or constant function is constant value only. Is it okay? See, rather than delta x here, you think x is limit x tends to 0, 5. At the time what you are going to write? 5 only. Here also limit delta x tends to 0, 2. That is equal to 2. Okay. Now you can say that f of x is equal to 2x plus 3. F dash x is equal to 2. Okay. F dash x is equal to 2. You understand? Understand it carefully. Then we go for another function, x square also. Okay. Say 5x square we go. Afterwards cube also we will go. Okay. One cube function. Afterwards constant function we go. Finally last. Okay. Note down this. We go for another example. Okay. See another example. Another example I am writing. You see. Let f of x is equal to 5x square. Find f dash x. Okay. This is the question. F of x is equal to 5x square. Find f of x. See, last function 2x plus 3. This is 5x square. That means power is 2. This also up to cube we do normally. Afterwards we generalize one formula like. But that is also not as per book. Book they have not yet gone. But I will tell you. Okay. Then we do constant function also. Okay. You see now. First you write f of x is equal to 5x square. Already they have given. Or else you write once again. And write the formula. F dash x is equal to limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Is it okay? Delta x tends to 0, x plus delta x minus f of x minus divided by delta x. Okay. And okay, write down now again. You substitute f dash x is equal to limit delta x tends to 0. Okay, you see, wherever x is there, there you have to write x plus delta x. Carefully you have to observe, okay? 5 into x plus delta x whole square minus 5x square fx divided by delta x. Okay? See, you should not write like this. 5x square plus delta x square. This is wrong. You have to write like this only. X plus delta x, entire thing. X should be replaced with x plus delta x. X should be replaced with x plus delta x. Entire the thing. Okay? Okay. Now expand this. Why? Because x plus delta x, a plus b whole square, like you have to expand first. Afterwards you have to multiply. Okay. That is equal to limit delta x tends to 0. 5 into a square plus 2ab plus b square. Or else, see what I am writing. 2 times I will write. Delta x square means delta x into delta x. Is it okay? A square plus b square plus a square plus 2ab plus b square. B square I have written delta x into delta x square. Why? Because not this is delta square x square, like delta x is itself one identity. That is why I have written delta x into delta x rather than going to get confusion like minus 5x square like that only divided by delta x. Is it okay? First you see. Okay, definitely okay. Now you open bracket. That means you send 5 inside. That is equal to limit delta x tends to 0. 5x square plus 10x delta x plus 5 delta x minus 5x square whole divided by delta x. Now you tell me plus 5x square minus 5x square. Shall I cancel out? Definitely I can cancel out. Okay. Now in next line, you see what happened. Okay, this is going to happen. That is equal to limit delta x tends to 0. 10x delta x. You first write, afterwards we will cancel out. 10x delta x plus 5 delta x into delta x divided by delta x. Now you tell me one denominator and multiple numerators can be accepted like LCM. Okay. But now if you see this delta x and one delta x going to get cancelled, here also one delta x going to get cancelled. Is it correct or not? Definitely correct. Then what will happen finally? This will happen, you see. Limit delta x tends to 0, 10x plus 5 delta x. Is it correct? Definitely correct. Now you substitute the value. That means delta x value you substitute. That is equal to 10x plus 5 into 0. Why? Because delta x is 0. 5 into 0. That is equal to how much? 10x. Why? Because 5 into 0 is 0. 10x plus 0, 10x only will come. That means for 5x square you have received 10x is f dash x. Or else you can write f of x is equal to 5x square, f dash x is equal to 10x. You understand now? Okay. You note down and we go for another function x cube. Okay. X cube also we have to see, and 1 by x also we will see. 1 by x also. Okay. X cube we will see, 1 by x we will see, then finally constant function we will see. Okay. Okay, note down this. We go for another example. Okay, see. Next function is x cube. Find derivative of f of x is equal to x cube. Simply I have written x cube, no 2x cube or 2x cube plus 3 or something like. For only x cube we will find the f or f dash x. Okay. See, first of all I am writing like this. F dash x is equal to f dash x is equal to limit delta x tends to 0. Okay. F of x plus delta x minus f of x whole divided by delta x. Is it correct? Okay. Okay, write down. Now that is equal to limit delta x tends to 0. See, f of x plus delta x. F of x plus delta x means what you are going to write? You are going to write this, you see. X plus delta x whole cube minus x cube divided by delta x. You see, where f of x plus delta x, there only f of x plus you have to write x plus delta x. That means x plus you are writing x plus delta x whole cube minus x cube f of x divided by delta x. This is very important. Okay. Okay. Now you expand this cube. Cube you know very well. Limit delta x tends to 0. See, what is a plus b whole cube? A cube plus 3a square b plus 3ab square plus b cube. Okay, this is over. Then you write this one function, then minus x cube. Why I have written rather than delta x square? See, for cancellation this will be very easy. Delta x into delta x square. 3ab square. 3a square b, 3ab square, b cube, delta x, 3 times if you write delta x cube. Okay. Now see, these two are going to get cancelled. X cube plus x cube minus. Is it okay? Okay. Now shall I cancel directly these delta x? Okay. Why you have write another one? You see, delta x, delta x, delta x, delta x. Okay. Now you write. That is equal to limit delta x tends to 0. See here 3x square, delta x gone, only 3x square will be there. 3x square plus here 3x delta x will be there. 3x delta x. Here delta x into delta x will be there. Sorry. Delta x, delta x. Is it okay? Definitely okay. See, denominator will not be there. Why? Because already we have cancelled out. Okay. Okay. Now you see what will come. If you apply this limit, you apply limit now, finally. That is equal to, you see 3x square will be like this only. Why? Because here no delta x, but delta x is here. Plus 3x into 0. Why? Because in delta x plus 0 will come. Plus 0 into 0. 3x square will be your final answer. Sorry. You understand now? 3x square. That means for x cube 3x square has come. You understand? Okay. So before going to further, I want to tell you. You see how these are coming? First question, we have seen 2x plus 3. For that 2 has come. Okay. You will pause and go back to video. The first question, example. Next question, I think 5x square. 5x square only, 5x square has come 10x. This question, this example, x cube. This has come 3x square. See, shall I write a derivative? Dy by dx is equal to, see, if y is equal to x power n derivative dy by dx is equal to n into x power n minus 1. Shall I write like this? But not now. See, we will do this practice only. Afterwards, finally, we will go. Some standardized form we will write all. Then we will do this. But you observe carefully, is this happening? If y is equal to x power n, dy by dx derivative is equal to n into x power n minus 1. As per this, you see, x power 3 means 3 into x power 3 minus 1, 2, 3x square. You see, x cube, 3x square. Okay. X square, that means 2 into x power 1, that means 2x. You see here, 2x. 5 into 2x. 5 into x square is equal to 5 into 2x, that is equal to 10x. Okay. 2x, that is equal to 2. But for constant function we have not yet got. So already we have told that derivative of constant function is 0. That is why we can say 2x plus 3 is equal to 2 plus 0. Why? Because see here x is there, that is not constant, that is why this value will come. But for this is a constant function, 0 will come. Okay. See, you just for understand, compare n into x power n minus 1. How this formula, you remember in limits also, x tends to n minus a power n by x minus a. N into a power n minus 1. This formula, do you remember? This formula. Okay, but here limit extends to 0. Sorry, limit extends to a. Limit extends to a should come here. Limit extends to a, x power n minus a power n by x minus a is equal to n into a power n minus 1. This formula I have seen. At the time only I have told. One link will be there from this formula, like important. You see n into a power n minus 1. Rather than a here, if you put x, n into x power n minus 1 is going to happen. But we will standardize this formula afterwards. Just you observe. Okay, as per this formula, if answers are coming or not, like that also you can see. Okay. Okay. What if 1 by x? Shall we write this as x power minus 1? Definitely. Then what will be the derivative? Minus 1 into x power minus 1 minus 1. That is equal to minus 1 x power minus 2. That is equal to minus 1 by x square. That means in the next function we are going to do this one. X 1 by x. Then the answer should come minus 1 by x square. Let us see whether that comes or not. Okay. Let us see. Let us go for another example. Okay. Now you see, you take 1 by x. Okay. 1 by x we are taking and we are finding derivative of this 1 by x. See how I am finding. Let f of x is equal to 1 by x, comma, and f dash x is equal to limit delta x tends to 0, f of x plus delta x minus f of x whole divided by delta x. Okay, this was the formula. Okay, we have written formula also. Now you substitute the functions in that formula. Okay, now you see limit extends, delta extends to 0 will be like this only. Okay, now you see in x plus delta x should come. See how I am writing. 1 divided by x plus delta x minus f of x, 1 by x. Is it correct? Definitely correct. If rather than this, if you write some other thing, if you write like this, wrong. Why? Because in x plus, entire x plus delta x should come. Okay, this is wrong. Like this you should not write. Okay. Okay. Now you do calculation. Why? Because cross multiplication you do numerator. Here see, numerator to a by b is coming, means here also delta x by 1 like you think. Why? Because you have to multiply afterwards this. Okay, that is equal to limit delta x tends to 0, cross multiply x minus x minus delta x, x square plus x delta x. Delta x by 1. Is it okay? First you see. First you understand it carefully. X minus delta x cross multiplication x square x delta x divided by delta x by x. Okay. Now you see, if a by b by c by d is there, like this, I am writing, you see. A by b by c by d is there, that is equal to a by b into d by c, you can write. Is it okay? Like this you can write multiplication. Now also I am going to write, but before that x minus x I am going to cancel out. Okay, that you see carefully. Here x minus x to be cancelled out each other. You see, x minus x, I am cancelled out each other. Okay. Now you see what I am writing. That is equal to limit delta x tends to 0 minus delta x divided by x square plus x delta x into 1 by delta x. See, when division delta x by 1, when multiply 1 by delta x. Okay. Now also you see delta x I can cancel out each other. The numerator is minus 1. That you keep in our mind. Okay. Numerator is delta 1. Sorry, numerator is minus 1. That is equal to limit delta x tends to 0 minus 1 by x square plus x delta x. Is it okay? Definitely okay. Now you substitute or else you apply limit, like you have to call it as apply limit. Now if you apply limit minus 1 by x square plus x into 0, that is equal to minus 1 by x square. Is it okay? Definitely okay. Okay. Why? Because in place of delta x 0 comes, 0 into x will become 0. 0 plus x square. Denominator. Numerator is minus 1 only. That means what you have received? If f of x is equal to 1 by x, f dash x is minus 1 by x square. You understand now? Like this I have done also. X power n is x power minus 1. This minus 1 x power minus 1 into x power minus 2. This is minus 1 into x power minus 2 only. Okay. Now I think x we have done, x square we have done, x cube we have done, 1 by x also we have done. Last one function, f of constant function, that we will do and close this class. Okay. Let us take any number, say 5, 6, 7, 8, 10, whatever it may be. Okay. Let us take one number constant function and we will do derivative of constant function also. Why? Because that should come 0. Okay. See, limit of a constant function is that constant value. Limit x tends to 0, 5 is equal to 5. Limit. Okay. Constant function. But we will see derivative, limit, both are different. Concepts slowly you have to see. Function and limit is different. Limit and derivative is different. Step by step we are coming. Function we have already seen. Limits we have seen. Now we are seeing derivatives. Okay. Okay. Now you see, let f of x is equal to 5. 5 only we will take. If f of x is equal to 5, then find f dash x or derivative of f of x. Okay. Derivative of f of x, like we are asking. Okay. Now see, again I am drawing this graph. One time I will draw a graph again. Why? Because see, for constant function, once I draw graph means you will understand, and next time you don't require any explanation. Okay. See, this is y is equal to 5. Is it okay? Constant function graph will be like this only, y is equal to 5. Why? Because there is no x. Why not 5x? Y is equal to 5. Y is equal to 5 graph is like this only. Okay. Now you see, This is x. This is x plus delta x. Okay. You have given x, you have given x plus delta x also. But do you see any change in y? This is your y f of x. But is there any change? F of x plus delta x? No. Why? Because see, this is a constant function. It doesn't depend on x. X may be negative also, positive also, any number, but y will be same. Okay, that means what you can understand, f of x plus delta x is equal to f of x. Is it okay? Why? Because there will be no f of x plus delta x. See, no means you should not write here 0. You can write like this. F of x plus delta x minus f of x is equal to 0. See, what is actually this? This is delta x is a change in input or domain. F of x plus delta x minus f of x is change in output, change in function. But there is no change in function. Change in function is 0, like you can take. Okay. Now you come back here. See, f of x is equal to 5 already given. Okay. Limit delta x tends to 0. F of x plus delta x minus f of x divided by delta x. Okay. Okay. This also we have written. Now you write here that is equal to limit delta x tends to 0. Okay. F of x plus delta x, what you are going to write? You are going to write 5 only. Why? Because see, f of x plus delta x is 5. F of x also 5 only. Why? Because there is no change. No change means original value. Original value is 5. 5 minus 5 divided by delta x. Is it okay? Okay. Okay. We understand now. Okay. Now you see again. Next step, what we have to write? Limit delta x tends to 0. 0. Understand now? 0. See, 0 by delta x is 0. You have not yet applied delta x. You have not yet applied limit. Before applying limit here, 0 has come. That you observe carefully. Before applying a limit, 0 has come. This 0 is like scalar. Now limit extends to 0, 5 means 5. Limit delta extends to 5 means 5. Limit delta extends to 0 means 0 only. Okay? That you keep in your mind. Don't think that 0 by 0 case 3. Why? Because see, 0 by 0 when after applying of delta x, then 0 by 0 should come. Here, for applying delta x is not there. Already this delta x, it has made 0. That's all. Okay? Now 0 has become constant or scalar like. Then 0 you have to take outside, then nothing will be there. What you are writing, limit delta, not limit x tends to anything 5. 5 means this is scalar function. That is why you are writing this as 5. Like this you have to think here. Okay? That means for constant function derivative is 0. If f of x is equal to 100, f dash x is equal to 0. You understand now? Okay? Okay. See, we have seen all of these functions. Square, ordinary function, linear, x square, x cube, 1 by x also we have seen, even constant function also we will see. We have seen. What we do, we stop this class here. In the next class, see, until now we have seen only this function, derivative, and we have not changed x here. In the next class, we will change x and we will find a trigonometric function also. Then we go for geometry of derivatives. Okay. See, concepts along with examples I am telling. You can understand it carefully. You can understand easily, and afterwards we will go exercise after completing of all concepts. Okay. Thank you very much.